In this video, we're going to be looking at electromagnetic radiation. Electromagnetic radiation is a very important aspect to us as it allows us to see, it keeps us alive, and it allows us to communicate over long distances. Electromagnetic radiation is a transverse wave that does not require a medium to travel through, which is why, for example, the sunlight is able to travel through space to us on Earth. There are many different types of electromagnetic waves, each with a corresponding wavelength. In ascending order, they are radio waves, microwaves, infrared radiation, light, ultraviolet radiation, X-rays, and gamma rays. As the scale goes up, each type of EMR increases in energy and decreases in wavelength, meaning that gamma rays carry far more energy than what a radio wave would. This speed is significant because as far as we are able to tell, it is the fastest speed possible in the universe. The photon is the particle which transmits the electromagnetic radiation, and is often confusing because it can be thought of as both a particle and a wave at the same time. To humans, much of the electromagnetic spectrum is very damaging to us. Luckily, the Earth's atmosphere filters most of it out. However, the higher up you go, the less filtered it gets, which is why, for example, they say when you're in an airplane, you're getting a chest X-ray, because that's the amount of radiation you're being exposed to. One of the most common uses of electromagnetic radiation is communication, especially through the use of radio waves. Radio waves can be bounced off the ionosphere using a sort of total internal reflection, which I'll explain later, which allows us to communicate around the world without having to relay the signal through a number of stations. One problem with using electromagnetic radiation as a form of communication is the inverse square law. The inverse square law states that I is directly proportional to 1 over d squared. What this means is that the intensity of the electromagnetic radiation is proportional to the inverse of the distance squared. Basically what this means is, say you have a source of light, its intensity will be directly proportional to its inverse of the distance squared. So its intensity, if you move, say, 2 units away from the source, will be 1/4 as bright as what it originally was. This can hinder communication because as the signal travels, it very rapidly loses intensity, making it much harder to detect. To fix this, you can either use relay stations which boost the signal again, or you can just make larger dishes that detect the electromagnetic radiation. Information can be sent through the electromagnetic radiation spectrum, specifically radio waves, through modulation of different elements of the wave. Amplitude modulation, or AM, is when the amplitude of the wave is modulated and the frequency is kept the same. This allows information to be derived from the different amplitudes along the wave. On the other hand, frequency modulation, or FM, is when the frequency is changed. Much like amplitude modulation, they use the different frequencies in the wave to receive the information from it. In general, FM is used more in music as opposed to just talking, because it has less artifacts or static in it. As always, there's some more study material provided below this video. Thanks.